Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This lesson is on sketching Lund graphs. I'm about to go through the second example, which is the equation y equals ln 2x plus 3 minus 1. And we're now happy with the idea that there's three things we've got to get right to sketch this graph correctly. We've got to get the shape, intercepts, and the asymptote. So I'm going to start here with the asymptote. And what we saw in the previous video is ln 0 does not exist. We're not allowed to ln 0. So if I make the bracket equal 0, I'm going to find the equation of the asymptote. So 2x plus 3 equals 0, which gives me x equals negative 3 over 2. So that is my asymptote. I can sketch that in straight away as a vertical line going down like so, and label it as x equals negative 3 over 2. Intercepts next. I'm going to look at my y-intercept, for which I'm going to make x equal 0. So if x equals 0, y equals ln of 2 lots of 0 plus 3 minus 1. So y is ln 3 minus 1. So that is the y-intercept. Now I just want to get a sense of whether that is a positive or a negative number. So I just type that into my calculator, ln 3 minus 1, and it's 0.0986, so it's a positive number. So I've got to think, okay, that is going to be above the y-axis when I draw it. And the reason I'm doing that is it gives me an idea of where my sketch is going to end up. So there's my y-intercept there. My other intercept, which is my x-intercept, I'm going to make y equal 0. So I'm going to write that as ln of 2x plus 3 minus 1 equals 0. Now, before I can apply e as the inverse operation, I need to isolate ln. I need to have the ln bit on its own. So this negative 1, I need to add 1 to both sides of the equation, which gives me ln of 2x plus 3 equals 1. Inverse operation of ln is e, so if I apply e to the left hand side it cancels out the ln, and on the right hand side I get e to the power of 1. Now e is a number, so e to the power of 1 I can just write as e. So solving that through, I would have x equals e minus 3 over 2. And again, I'm just going to check on my calculator what that looks like as a number. So e, you'll need to put in the number 1, so it knows you're doing e to the power of 1, minus 3 all over 2, and that's come out as negative 0.14. So it's come through the negative part of this x-axis here, which should hopefully make sense because the y-intercept is positive, the x-intercept here is negative, so what I'm going to get for my sketch is something that looks like that, and then I'm just going to label my intercepts, and I'm going to label them with exact values. So this one here is 0, ln 3 minus 1, and this one here is e minus 3 over 2, 0. Asymptote for x equals negative 3 over 2. Just a point about these ln graphs generally, it looks as though this ln graph is flattening out. We're not going to get a horizontal asymptote going across here. What's happening is this ln graph, it is continuing to increase in value, but it's doing it at a slower and slower rate, which makes it look like it's flattening, but it actually isn't. Okay. One more example to go, I'll see you then.